the magnetic property of metals based on electronic configuration. But before that, let us review what we have discussed in our previous lesson. Are you ready? Alright. Write down the electronic configuration of silicon. Okay, if you wrote the long method, that is correct. However, we have another way of writing it, or what we call the noble gas or the shortened method. And if you write it this way, that is also correct. Okay, are you ready for our new topic? Well, not yet, because I will be sharing to you our objective. Okay, our objective for today's class. Let us read. Okay, ready? At the end of the class, I can determine the magnetic property of an atom based on electronic configuration. Very good. Okay, before anything else, let's have our trivia time. First trivia for today. Did you know that? Did you know that the first people to discover the magnetic rocks were the Chinese? They call it the love stone because stones love metals the way parents love their children. At first, the Chinese used the stones to carry out fortune telling and magic tricks. Did you know that? Right, now you know. Another trivia for today. Did you know that birds can see the Earth's magnetic field? Wow! Now you know. Sana all birds, right? Alright. So let us now go or proceed to our topic. So we will first discuss the paramagnetism. So when we say paramagnetism, the electronic configuration, it is when the electronic configuration of an atom results in an unpaired electron, meaning that the atom or ion have a net magnetic charge. That is called paramagnetism. Okay, let us take a look at this example. Can you see the nickel? Right. The electronic configuration of nickel is written below. As you can see, the last two parts, see that? Correct. You can see two unpaired electrons. So that means nickel is a paramagnetic element. Correct. Now, what are other characteristics of a paramagnetic element or atoms or ion? Actually, the paramagnetic atom will be attracted to a magnetic field. Example of these atoms are elements, rather, are aluminum, gold, and copper. Do you have any questions about paramagnetism? Again, when we say paramagnetism, that is unpaired electrons. So, what is the relevance of these paramagnetic atoms in our everyday life? Actually, paramagnetic atoms are used in MRI. Are you familiar with this? Paramagnetic atoms are actually used in medical field. That is, MRI is an example. So when we say MRI, that is a non-invasive imaging technique. Okay? So are you good with that? Okay. Now, let us proceed to our second topic. So our next topic is about diamagnetism. So what is diamagnetism? So it is when the electronic configuration of an atom results in a paired electrons, which means that an atom or an ion has no magnetic field. So that is what we call diamagnetism. Alright, again, when we say diamagnetism, it is when the electronic configuration will result to a paired electron. Let us now take a look at our example. So when we, as you can see here in our example, we have the sodium chloride or our salt. If you will write the electronic configuration of the sodium, see, the last two electrons are paired. How about the chloride ion? Correct. The last two electrons are paired. Therefore, sodium chloride are diamagnetic substance. Are you good with that? Great. So what are other descriptions of our diamagnetic elements? So when we say diamagnetic atoms or ions are slightly repelled or not attracted to a magnetic field. So the examples of this one are bismuth, silver, gold, marble, and water. So where can we use the diamagnetic atoms or materials or elements? So for example, we have the bismuth that is used in guns. As you can see here, why do we use a diamagnetic in guns? Because as you can see, there is no reaction to a magnetic field. Therefore, if we fire a gun, it has a less interaction with the Earth's magnetic field. Are you okay with that? Great. So, let us now compare our two electronic configuration. So, as you can see here, we have the paramagnetic and the diamagnetic. When we say paramagnetic, as you can see, it results to a paired electron. How about the diamagnetic? So when we say diamagnetic, that has a paired electron. Okay, let us recap. When we say paramagnetic, that is unpaired. When we say diamagnetic, that is paired electronic configuration. Any questions? Okay, you can PM me your questions about this topic. So now, let us check your understanding about the topic. So, identify whether the element or metallic ion is a paramagnetic or diamagnetic one. Are you ready? Okay. Please write the electronic configuration of this one first and then see if they are paramagnetic or diamagnetic. I'll be giving you 1 minute to do that. Alright, 1 minute is up. So now let us check for your answer. Here is the electronic configuration of chromium 3+. As you can see, it has what? Correct. Unpaired electrons. So therefore, chromium 3+ is what? Correct. A paramagnetic ion. Now, let us proceed to zinc 3+. As you can see here, this is the electronic configuration of the zinc 3+. As you can see here, the electronic configuration are paired. Correct. So they are paired. That means that zinc 2+ is a diamagnetic ion. So that means that the zinc 2+ is a diamagnetic ion. Are there any questions? Did you get our lesson for today? Alright, so if you have any questions, please send me a message and I will be willing to assist you anytime.
Alright, thank you so much for watching. I'm Jonaya Amer, your General Chemistry 1 teacher. And if you have any questions or clarifications about the topic, don't forget to send me a message and I will attend to you as soon as I can. Thank you so much and goodbye, class. Keep safe, everyone.